In the previous video, we introduced the interpreter and briefly demoed how it could be used interactively. In this video, we're going to introduce scripting and show you how you can create files containing your Python code to allow you to more easily run commands outside of an interactive session. A script is really just a text file containing some Python code that is executed by the Python interpreter. Typically, script files use the extension .py and are plain text files, meaning that they are ASCII or UTF-8 files. Now, to create a script file, you can really use any application you like, as long as that application will save your files or your script file as a plain text file. For example, on some systems like Mac, there are built-in text editors that may save text files using other formats than plain text. The text edit application in Mac OS Catalina was one of these applications. If you saved your text file, it would actually use a rich text format, meaning that if I were to enter, say, the for loop here, then the file that text that it creates would actually contain all of this information here and not just the Python code containing my for loop. And so you see here that I have all sorts of formatting and other commands that are not actually Python code. And if we were to pass this to the Python interpreter to be run, it of course would fail since it wouldn't know what all of these things are. Now, you more than likely aren't going to use this particular application, but I wanted to show you that when you choose an application in which you wish to write scripts, then make sure you find something that saves to plain text. And if you're using some sort of IDE, then you probably don't have to worry about this at all because they're built specifically for handling code and won't add all this additional formatting for colors and fonts and so forth. Okay, so I'm going to use the Jupyter Notebook interface itself here for this example, but I'm going to create a new text file. So I click New, select Text File, and I'm going to rename the file to ex.py. Now, the name of the script can be whatever you like, but do make sure you put the .py extension. Typically, the name of the file is something that describes the content or the function of the script, so make sure you choose appropriately for your own scripts. Now, for the contents of the script, we're going to keep this simple, and I'm simply going to write a for loop. So I'm going to write for I in range 10, and then I'm just going to print I to the console. So we'll discuss loops in more detail when we get to control flow. But for now, this loop is going to simply call the print function 10 times, passing the index I during each iteration. And this is just going to print the numbers 0 through 9, each on a separate line. So now we're going to save our script, and then I'm going to switch over to a terminal where I've already navigated to the directory containing the file we just created. So if I list the contents of this directory, we'll see our Python script, ex.py. Now, to actually execute or run our script, we can pass our script as an argument to Python as follows. I'll say Python, and then pass our script as an argument, ex.py. And we see the output of the print function 0 through 9 right here immediately. Now, we can actually run this script without explicitly passing it to Python as we did here. We can simply write the file name directly to prompt. Now, before I hit enter, when you enter a command at the command line, your OS will search for the appropriate executable with that name. The set of directories that are searched is stored in your environment in a variable named path. That's PATH in all caps. Now, quite often a user's path does not contain the current directory, meaning that when we attempt to execute our script, the OS will not search the current directory for it. So to get around this, we can either give the full path to our executable or a relative path. A relative path is most commonly used since it's much simpler. And to do this, the current directory, no matter where you are in the file system, is represented by a dot or period. So I'm going to enter // and then our file name. Note that I'm on a Mac, and Windows users will likely need to use the other slash when specifying a relative path. Also, the last time I checked, Windows 10 did include the current directory in the search path by default. But with the // the OS actually doesn't have to search for the file since we've given it a path relative to our current location in the file system. So now I'm going to hit enter. And so we see that the OS says permission denied. Windows users are likely to get the expected output of 0 through 9, as two things happen there. First, the permissions are handled a little differently. And second, our file name had the .py extension, and so Windows will actually look at that extension to decide how to handle the file. Linux and Mac, on the other hand, are going to require us to specify that this file has execute permissions before the OS will allow it to be executed. So if I list the contents of the directory again, but this time I asked for the long format using the -L, we see that for this file, I have read permission, which is specified by the R here. I also have write permission, which is specified by the W here. Read permission allows me to open and view the contents of the file. Write permission allows me to edit the file and save those changes. The next dash here represents execute permission, and I currently do not have execute permission. So since we want to execute the script, I need to change that using change mode, or chmod, to do this. So I'm going to write change mode plus x, meaning add execute, and then the name of the file that we wish to add execute permission to. So this is ex.py, and then I'm going to hit enter. And if I list the directory again, we'll see that now the X appears here, indicating that we can now execute this file. So we're going to do ./ex.py and hit enter. So what happened now? Well, the system doesn't actually know what kind of script this file is. Yes, we've given it the .py extension, but Linux and Mac don't actually use that necessarily to decide how to execute a file. Instead, we need to add something called a shebang, or a shebang line. Now, shebang is the hash symbol immediately followed by an exclamation point, which is also known as a bang. So the name for this set of characters actually comes from these two symbols, hash, bang, or shebang for short. Now, if this set of characters appears on the first line of a file, they are expected to be followed by the executable that should be used to process the file, meaning that if we wish for this script to be processed by Python, then we need to specify the shebang followed by the path to the Python executable. Now, we have several options for specifying the executable that we want to process our script file. On Linux and Mac, we can use the environment to find Python 3, as in the first example here. Or we can specify the full path to Python 3, as in the example here. Now, do note that if you have multiple installations of Python, that it may be better to allow a user to define this in their environment rather than guessing at which installation they wish to use. So in the second example here, we're assuming the installation in user bin is to be used. Now, you can, of course, omit the path or the environment entirely and simply write Python 3 as we have in this final example. And this will use the user's or system path to find Python for you. So these examples here are actually what's more commonly used in the systems. But of course, their usage is going to vary depending on your setup and preferences. So we're actually going to use the first example here since I'm on a Mac. So as I said, the shebang line needs to be the first line of the file. So I'm going to add some space here and then just paste in our shebang line. And now I'm going to save our file. And then I'm going to return to the terminal. And one more time, I'm going to type ./ex.py and hit enter. And finally, we see our output 0 through 9, each printed on a separate line. So we went through all those steps just to show you that, especially on Linux and Mac, you do need to specify a shebang line so that your system knows how to process the script file itself. And you also need to give it execute permission so that the OS will allow you to run this file. And on Windows machines, again, it's going to be a little simpler for you as long as you use the .py extension. So we've already touched on the path in your environment, but I've written this section here to give you a little bit more detail on that in case you'd like to know more. But we're going to continue with running scripts from within the interpreter now. So I'm still in the same directory as our script, and I'm going to start the Python interpreter. And to run our script, I'm actually going to use 3 functions to do this, the open, read, and exec functions. So I'm going to type this whole command out, and then we're going to discuss each part. So first, let's take a look at open.expy. This function is going to first verify that our file, ex.py, exists in the current directory. And then it's going to create a handle, or an object, that represents that file. We're then going to call the method read on the newly created file handle object, which actually reads the contents of the file. The contents of the file are then passed as an argument to the exec function. And the exec function will actually interpret all the commands passed to it as Python commands, thus executing our script. So when I hit enter here, you'll see that we get the output 0 through 9, as we would expect. Now, I went through that pretty quick, and don't worry if you didn't follow every part of it. We're going to discuss functions, arguments, and everything involved in this in future sections. For now, I just wanted you to know that you can place the name of a script between quotes here, and this line would actually execute your script from within the interpreter. And actually, there are a couple ways you can do this. This is just one example. In fact, in the notes, if we scroll down, you'll see that there's an example using subprocess, which is yet another way to execute Python scripts from within the interpreter. Again, don't worry about the details just yet. You can really just replace the file name here with your own and simply run the command. We'll talk about processes and related topics once we get to the section parallel program.